This is hazards of radiation, mutations in somatic cells. In a somatic cell, which will continue to divide, a gene mutation will be transmitted to all descendants of the originally affected cell unless the mutation kills the original cell. A dominant or hegemonious sex-linked allele will phenotypically have normal descent. Since the majority of mutant alleles, irradiation of part or all of the body will produce mutations in applicable number of billions of cells which constitute an individual. These mutations are recessive and they will remain unknown until perhaps years later, maybe attained in one's somatic descendants. Propagation of the homogeneous recessive cell may then result in visible effects. Irradiation may be explained by this process. Spontaneously occurring mutations, medical exposure. As a result of diagnosis and treatment, the total amount of accumulated irradiation received during a lifetime in any part of a patient's body is usually below 50 R. Not many individuals ever receive much as 100 R, through occasionally much larger doses have been administered. From the point of view of later generations, only a radiation which hits the gonads is of importance. It's obvious that even exposure of the gonads is of no consequence after an individual has ceased to have children. The average dose of the gonads administered per session varies according to different medical practices in different countries. In the United States, it's estimated to be 3 R per 30-year period, where R is rads. Appropriate accumulated chronic natural background radiation. Occupational exposure. Physicians, X-ray technicians, and investigators. When it became known that radiation can cause harm to individuals such as burns and anemia, occupational protective measures were introduced to limit the amount of radiation reaching the body. This protection is primarily in the form of lead or concrete shields, which absorb most of the radiation. With military exposure, nuclear explosions result in a nearly instantaneous production of immense amounts of highly penetrating radiation and cause contamination by radioactive fallout of large areas. Within this area reached by direct ionizing radiation, great amounts of radioactivity are induced. The dose of irradiation received by an individual depends on his distance from the center of the explosion. Most individuals who are near enough to receive a total body irradiation of about 450 rads or more do not survive. Consequently, the highest rate of induced mutations that may be transmitted by a survivor corresponds to less than 450 rads. That is, to about 9 times the natural gene mutation rate. Radioactive fallout following a nuclear explosion can cover with high concentration hundreds of thousands of square miles, or in lower concentrations the entire globe. The tests of atomic weaponry by the United States, Russia, England, etc. have resulted in the production of large amounts of radioactive fission products, of much of which are presented in the upper layers of the atmosphere. These products slowly fall to Earth. In 1958, the total amount of very low intense radiation due to fallout which had impinged on In 1958, the total amount of very low intensity radiation due to fallout which had impinged on the average individual was estimated to be in the order of 0.1 rad. Even though further tests have conducted, this dose will gradually increase, perhaps too much accumulated much as 0.3 or 0.5 rad. It's possible that the amount of radiation exclusive of that from military sources to which men may be exposed will increase. The use of radiation for medical purposes will spread to many countries. Peaceful applications of atomic energy will create new sources of radiation, including those from radioactive waste products. Several proposals have been made to keep the mean exposure of individuals in large populations to at most 10 rads per 30 years. A figure that sometimes includes background radiation, sometimes in addition to it. This amount of radiation, as we'll see, has far-fetched consequences, particularly in the exposure occurs of high level of intensity. We are still considerably below such exposures. In the future, it may be well decided that a reduction of the so-called permissible population dose is an imperative. Radiation-induced mutations may occur in two basically different anatomical regions, the body cells and germ cells. The somatic mutations are not transmitted to later generations, but may cause changes in the irradiated individual. Gametic mutations may be transmitted to the offspring, but will not affect the irradiated individual. Therefore, since irradiation of an individual may produce mutations of both somatic cells and in his germ cells, some effects may be produced in his body, his and or her, and others quite different kind may be transmitted to his offspring. And mutations of somatic cells. Okay. End note.